Hello and welcome everybody. We are going to talk about knowledge graph and how to build it using Advertools and WordLift. I'm happy to introduce you our guests, Elias Dabas, author of Advertools, and Doreid Haddad, SEO expert at WordLift. Welcome and thank you. So let's start the presentation. And if you have any question, you can write in the chat. So go.
Thank you very much. Let me 1 second share my screen. Can you see my screen?
Yeah, it's arriving.
Okay. Thank you, everyone, and welcome. And I hope you enjoy this talk about knowledge graphs, creating them with Advertools and WordLift. So the basic idea is we all know that search engines are very smart and very advanced in understanding content. But even the most advanced search engine has to try to figure out something using some advanced machine learning algorithm or artificial intelligence or something like that. But what we can also do is we can present the data to search engines in a very explicit and standard format so that they can extract the information very explicitly, just like they deal with an Excel sheet. So basically, the page will declare itself as containing a content of type, let's say, recipe. And because it's a recipe, it would have the attribute ingredients, and there would be a list of ingredients. If it's of a type of article, then it would have an author, and so on. So we're going to go through a process of doing this. There won't be any coding in this session. So if you're not familiar with any programming, it's absolutely fine. You'll be able to follow along. However, we'll be sharing some of the functions that we use, and you'll see that many of them are very straightforward to use. Now, the full code is available in the notebook, also in the link that you can have in the videos. So let's start with looking at the plan of this project that we did. So the first thing is just keep in mind, please, that this is one possible workflow out of many other options. This is one case, and we hope that the tools that we share show you the flexibility and power you have to customize them in any way you want. So we're going to start by exploring a website by downloading its XML sitemap. We have an imaginary client who wants us to go to the website Farfetch and go to the UK website and look at women's jackets. That's the requirement from our imaginary client. So we're going to extract those URLs from the XML sitemaps, and then we're going to crawl them, and we're going to extract the content and the data that we need from those URLs. We're going to do some visualization to understand what the data tell us. I think this is extremely important. I see a lot of work in data science and Python for automation, which is great. But I also think we should also focus on insights and understand what the data we have is, and not just blindly do some automation. We need to understand what's going on. Then we're going to create the linked open data with what we have scraped, and we're going to use WordLift's API, and then we're going to see how to deploy to the relevant pages. Okay, so let's start with the steps that we took to run this. So if you're not familiar with any coding, I just want to show you that this is very similar to the way spreadsheets work. So basically what you see here is I'm defining a variable. Okay, the variable is called A1 by default, and I'm saying A1 is equal to function name, and I give it some arguments. So A1 is equal to the sum of the numbers 1, 2, 3, 4. And the same thing works in programming languages. So I'm creating a variable here called ffrobots, Farfetch robots, and it's equal to, this is the function name, robots text to df, of this URL. So it's the same exact thing. The difference is that the name of the variable, I can do something descriptive. So next time I read the code, I know what's going on, or if someone is reading with me, they would know what this is instead of A1 or A2 or A3. Okay, so we have three main functions over here that work pretty much in the same way. they all end with 2df. And df is short for data frame, which is basically a table, just a table. But that's the usual word that is used in data science. So we have a function that converts a robots.txt file to a data frame. Then we extract the sitemap from that. We have another function that converts a sitemap to data frame and URL to data frame. So one interesting thing about the sitemap to df function is that if it detects that the sitemap is a sitemap index, it would go recursively by default and download and parse all the sub-sitemaps that you have. So if you have 100, it will parse them all. And it's recursive, it's true by default. Now, in this case, because we still want to explore the website, and because it's a very large website, we don't want to spend hours or many minutes, I don't know how many it would take. So just what we're saying here, convert the sitemap to a data frame, recursive false. Just download this sitemap and parse it for us. And once we do that, we can use the URL to df function, which means we convert the URLs in that sitemap to a data frame table format. So in order to see this visually, to make it easier, this is what we start with, an XML sitemap. And then with sitemap to df, we get a data frame of all the attributes over here. Then we extract those URLs and we split them. Okay. Now these are a small sample. These are like 5 URLs from the sitemap index. And this is the URL, and these are all the components of the URL. So we can play with it the way we want. The scheme, network location, the path, query, and format. Now the path part of the URL, which contains content, is split for us into directories. Excuse me, directory 1, directory 2, directory 3, however many we have. So when we looked at these, we saw that directory 1 has sitemaps. Okay, not much information there. Here we have sitemaps farfetch.com. Again, nothing much. But here there seems to be a lot of information telling us about those sitemaps. So the first thing is we have the country code, the 2-letter code at the beginning over here. And then we have the type of sitemap. So this is sitemap brands, categories, brands, subcategories, and so on. So one thing we can do is, let's see how many. Let's take the first two letters and see what countries are available. So extracting the first 2 letters and counting them, we're starting now to build our understanding of the website. Now we see the countries that they operate in, and we see for each country how many sitemaps they have, which is an indication of how much content they have per country. So that's starting to build our understanding of the website. So the target country is the UK, okay? Because this was specified by the client, and as you can see, we have 20 URLs in the UK. So we can extract these simply as you extract them from an Excel sheet, and here are the 20 URLs from the UK. So the names of those sitemaps are nicely created for us. You can see what these sitemaps are for, brands, categories, and so on. And the ones that we're interested in, because we want women's jackets, that was the specification, it means we are interested in the products sitemaps. So it seems we have 10 of those over here. So what we did is we downloaded those 10 sitemaps with the function sitemap to df, and then we filtered the ones that we wanted, which are jackets. And then we split those URLs, and now we can analyze them even more. So these are the URLs, as you can see here. Directory 1 is all UK, shopping, women. And then we filter by anything where directory 4, or the last directory, in case it's the same thing, contains the word jacket. Now, another piece of interesting information that we get from this filter is right over here. So this tells us that we have 8,521 jackets on this website. So again, this is building our knowledge, our understanding of this site. So if we have 100,000 products on this website, then we know that 8% of them are women's jackets. So we can do the same thing for shoes, for skirts, for dresses, whatever, and we can see the relative importance and how much they they give importance to those products. So we're getting some insights. So now what we are going to do is we're going to crawl these URLs, the ones that we wanted, that identified according to the requirements, and we're going to extract the information that we want. So this is another function we have. It's called crawl. I'll get to this in a moment. It's another function from Advertools. It's very straightforward and very simple. It requires 2 arguments, a URL list, which in this case, we're going to take the jackets. We took a sample of 250, but you're free to crawl the whole thing as much as you want. So a URL list and an output file. Output file is basically what's the name of the file where you want this crawl data to be saved in, and it just has to be in the format of JSONlines.jl. That's it. That's all you need for the crawl function. Now, the crawl function has many other options and combinations of options that control the behavior of crawling, and if you want to follow links or not, if you want to extract with custom extraction, many other things. And one of these options is XPath selectors. So we're going to use this optional parameter today. And the XPath selectors is XPath selectors, which was defined over here. So from every page, if available, what we're saying here is we want the meta tag that contains the item prop attribute, and we want the item prop attribute itself extracted. Also, from that same meta tag, we want the content of this attribute. So basically, this would be color, and this would be blue. On the same page, we'd have another meta tag that says size small, price 10, and so on. Okay, so this is the custom extraction that we're going to make, and this is going to cause the crawl data set to contain 2 columns that I named item prop and item prop underscore content. You can name them whatever you want. So just like the other functions we ran, just like in Excel, you have a function, you hit enter, and it runs. And after we crawl those pages, we can now explore the columns that we are interested in. So here's a sample of one of the URLs that were crawled. This is the same URL duplicated. As you can see, the index is all 0. So we can map everything together. And now you can see that this jacket has this name. The SKU is this. The color is blue. Here's the description and various other data about this jacket. Now here's another URL with the same thing, but it has slightly different attributes and values on the page. So now we have the item properties and content listed in a very easy to use format. It's like basically an Excel sheet, so we can use them the way we want, and we can deploy them in an easy way. The other thing that we're interested in are images. Now, because these are fashion products, they're visual, people need to see them, and it's good to show these products. The image source attribute is extracted for us automatically. We don't have to do any special extraction for it with the crawl function. So we just have to go to the image source column, and here you can see that every page has 3 images. Basically, one showing the jacket on its own, the other one showing the jacket worn by a model, and another one which is very small, which is basically a thumbnail. So now we've extracted the content that we want. We have it in a very easy to use format. We have the content, the item props, and the content, and we have the images, and we're ready to deploy. But as I mentioned at the beginning, I think it's very interesting to know something about those products. Again, you don't want to just deploy blindly. You want to know what's going on. It's also good in terms of understanding the business and the strategies. So one straightforward thing we can do is explore the prices. So how much does a typical women's jacket in the UK website of Farfetch cost? Is it like 30 pounds, 50 pounds, 200, 5,000? Make a guess. It's a very simple thing to get. We can plot them here in this simple histogram and see that the typical jacket is in this range between 200 and 600 pounds. And then we have a bit more, and beyond 4,000, it becomes an exceptional case. We have a few exceptional cases here, but you can see this. So if there was a competitor where the prices of jacket is like 20 and 30, that's much below our audience. If there's another competitor with jackets of 4,000 and above, we have these, but that's the exceptional case, but the majority are here. So another thing we can look into is the colors, because we have the colors. It might be interesting to see what kind of colors are the most popular. So make a guess. What's the most popular color of the jackets? Again, it's very straightforward. We have these colors and we count them. Some processing here, because some of the colors are not just the name of the color. You have 900 black, 999 black, and so on. And these are the most popular colors that are available on the website for jackets for the sample that we've extracted. So black, white, blue, pink, and so on. Another thing that would be very interesting to know is what type of jackets do we have, right? Are they crop jackets? Are they leather jackets? Are they hooded jackets? Make a guess. What do you think is the most popular type of jacket that's on display or listed on this website? So again, it's a straightforward thing because we have the product names, and each product name here has two lines: the name of the product, and the brand, the name, the brand, and so on. So we know that this jacket, for example, is a zip-up and hooded jacket. Okay, this is padded and hooded. So now we have two hooded jackets, and so on. Now, here are the most popular types of jackets based on the words used in the description. This is the same. This is the exact chart, but this is a percentage, and this is absolute counts. So it was interesting for me to know that there was not one type of jacket that's dominant. Like I thought maybe leather jackets would be 30%, or like no, but the top one is 2.5%. So they're more evenly distributed, and that's the kind of stuff that is interesting to know about, I think, in addition to the automation and creating the knowledge graphs. So now we have the full data. You can slice and dice the way you want. These are just very small examples. We're ready to deploy, and this is what Doreid is going to share next to show, and then we can have more discussion and questions if you have. Doreid?
Yeah, thanks, Elias, for this first technical part. I mean, all the explanation that you did. Let me share my screen and
sure.
And
stop sharing.
I mean, how we can use this stuff. I mean, for the SEO purposes. Let's see, you see my screen right now?
Yes.
Okay, good. So this, I mean, first start by a very simple approach. So why do we need the data set, basically? I mean, how I can use basically all the informations or all the data that has been scraped before in order to, let's say, not increase the organic traffic, but first of all, I mean, improve the business itself. So one thing here, I mean, I would like to highlight that besides having, I mean, benefits from the search engines, from Google, from Bing, from any search engine, it's good to have your data set, because with your data set, you can do a lot of stuff. I mean, that go further, I mean, than the SEO. So this is one thing. Second thing, I mean, right now we will see how we can use this data in order to grow the business. So basically how we can improve the user intent on our website, how we can get more organic traffic, how we can, I mean, get more sales in this case, because we are speaking, for example, right now about e-commerce website, but I mean, the approach is the same, whether it's an e-commerce or any other business. So basically, I mean, those are the different steps that we follow in order, I mean, to achieve our goal here where we want to improve the SEO. So we start with scraping for the web pages, as Elias was explaining. Then we move and we organize the data that we have in a search-friendly way. So when we speak, I mean, about organizing the data in a search engine way, here we always come back to our, let's say, schema glossary, because this is, I mean, the language that the search engine can understand. So we bring all this data that's been scraped, everything that we have, we reorganize it in such a way that the search engine can understand. Then we can move forward after, I mean, with submitting this data for the search engine. measuring the impact that we have and keep improving the data, which is, I mean, an interesting thing, because every day we have something new. We know, I mean, every day, for example, Google asking for something new, we can always come back to our initial data set, we can improve it, then we can work, I mean, on bringing in new properties, for example, on the schema markup that we have, in order, I mean, to stay ahead of the competition. So how we do this stuff here, I mean, I would like to speak about how search engine has been, I mean, moving in the last year, and the approach of the web pages and the data set. So we all know, I mean, most of us think in terms of web pages. So we have a web page, we try to do, I mean, let's say you activities on this web page in order to improve the ranking. So we focus on content, we focus on page optimization, we focus on performance, all this stuff that all people know. But in addition to this, and the most interesting thing that, I mean, not a lot of people focus is the data set behind. So what are the information that I have behind my website? This is very important because, I mean, right now the search engines are intelligent. They can crawl the web pages, but also they can go further, and they can also crawl this data set or this knowledge graph that you have behind these pages. One clear move that has been done by Google in 2020, we know that Google, I mean, has moved the Google Shopping from the pay-to-play model to the organic. I mean, why? I mean, a company like Google do such a step? Why they move from pay-to-play model to organic? Because they need data, of course, and for, of course, I mean, other commercial reasons, because the competition for Amazon and all this stuff. So they decide to render this I mean section of Google free for everyone. And the first thing that they do, why I mean choose this example, is the dataset behind. So if we come back, I mean, just to see what Google asks, for example, in order to show the products inside the Google merchant, they ask something like this. So this is, I mean, the Google merchant feed example for the data. This explains in a clear way why Google or other search engine need data, because with this data, they can do a lot of stuff. They can, I mean, show the products on their shopping platform. Then after, I mean, we will see they can show the products in the images. They can show the product in the product knowledge panel. So they can do a lot of this stuff. And the game is easy. I mean, more information you can provide the search engine with, the more trusted that you can get from the search engine. And of course, the more visibility you can get there. So this is, I mean, the approach behind the data set in general, and how we can use it in order, I mean, to get more traffic. So here, for example, we build a markup for a product. So AWS has crawled the websites and bring the information from that websites. Basically, from the dataset that he provided, we were able to bring and build the product markup. Of course, I mean, when the crawler arrived to the product pages, they can see all the information that we have in the page. And this, of course, I mean, will help getting more traffic and get all the, I mean, the future snippet results and all this stuff. The cool thing here that we can play, I mean, with the different data source that we have, because, for example, I can bring some of the data from the merchant feed that I have, but I can also enrich it, and I can also bring, I mean, data from the scraping work that has been done by Elias, for example. So this is the initial, for example, setup that we have that includes basic information like the URL, the description, the image, the SKU, the offers, the brand, all this stuff. But then we can also build on this, because we know, I mean, merchant feed is limited, but the structured data can be used in more advanced ways. So, for example, we can add other properties that we have already there in the page. And this is the cool thing, because we don't have, I mean, to go and create the information. It's there. So we just need to bring it, build the dataset, and provide it for the search engine. Here, for example, from this page of this websites, we can bring information, for example, the country of origin of the product itself. We can also, I mean, bring information like the model. We can also go forward and provide information related, for example, to the product size, the height, the width, the depth, all this information we can bring in because it's those are properties present there in the product markup of the schema. We can also bring other information related to the shippings, for example. The shipping details is quite important, and it's also a game changer because I mean, imagine put yourself in the position of Google. I mean, if I have, for example, an e-commerce and I'm providing the shipping rates and the shipping details, how much visibility I can get more just by providing this kind of information. So those are, I mean, quite important. This is, for example, a product markup that we built. So we bring the data that Elias has created. We build, for example, the product markup. We enrich it. Then we can add, of course, on this properties that we get. So all the information, for example, related to the shipping details, it can be injected to our knowledge graph, and after it can be translated to search engine language using schema. The same is valid for the SKU, the GTIN, the global identifier, the review, the aggregate rating. So all this information really can be brought from the web pages and after transformed in knowledge graph that the search engine can consume. Of course, why we need this stuff? I mean, this is basically what we are doing with the WordLift, and I'm the senior SEO in WordLift, by the way. And in the last 3 years, I've been focusing on this stuff, especially on the e-commerce platforms. So here, I mean, for example, what we can do with this data, we can bring it. As I explained, we can build this knowledge graph. But the most important thing is measuring how impact can make on our SEO. And this is, I mean, a clear slide that can explain how benefits we can get from this implementation. So we start always with our website. Then basically, I mean, we build the knowledge graph. Here we are using WordLift to build the knowledge graph. Once we have this knowledge graph, we provided the search engines. And basically after, I mean, the search engine will be responsible to provide this information in different forms. So for example, here we choose the product markup. We see that Google see this stuff, I mean, as a feature results. Google can use the aggregate ratings to show it, for example, in the product knowledge panel. We can get more visibility on the images itself of Google. You see, for example, also Google can use the same information to show the shipping details as a feature result as well. So all these platforms or all this, let's say, serves, Google can use it in order, I mean, to show your product for the right user. So more information, I mean, I can provide the search engine with. More enrichment I can add to my knowledge graph, to my product markup in this case. More trust I can get from the search engine, and of course, more visibility I can get. Then, of course, we can use the same knowledge graph, I mean, for other purposes. Let me show you, for example, here. Here, for example, I have the data set that has been provided by Elias. So basically, also we can play with it. So when I use, I mean, the graphic URL, for example, I can make any call from this data set, and also I can enrich it. So I can also bring all the information that is behind, and then after, I mean, play it as I prefer. So it's a similar approach, this one, to what we have inside the. Sorry, I lost my screen here. So it's have, I mean, a similar approach to the headless CMS basically, and we can use it, I mean, for different purposes, whether for SEO or whether for improving, I mean, the same knowledge graphs that we have. And yeah, this is more or less, I mean, what we can do basically with the knowledge graph. I believe we can move for the questions right now.
Please, any questions?
Let's see. I know. I mean, we bring a lot of.
It's 100% clear. That's why there's no question.
Yes, exactly. So I have a question, more or less. So we're talking about e-commerce, but this workflow is it works also for other type of website, right?
Yeah, exactly. This is, I mean, a very good question, because why, I mean, we choose the e-commerce, because, I mean, it have a lot of properties, a lot of data, and can explain the idea in a perfect way. But the same approach is, I mean, valid for any other kind of a schema. So whether I have, for example, a travel agency, okay, and I want to get more visibility, I can provide all the information related to the package that I have, the travel destinations, all the information, I mean, related to this stuff, basically. So it can be used in very different ways. This is one example. I can also, I mean, if I have a business, the same approach. So if I have a service that I can provide, I can do the same stuff. So it depends on the kind of the business, but the same product markup is valid for the service markup, for the insurance company, for the travel agency, any kind of businesses. We can build the data set, and after from the data set, we can build any other schema markup that the search engine can consume.
Okay. And so what are the challenges when scraping a website?
No challenges. It's very easy. Just joking. There's well, so there might be some non-standard markup on the web page where it's inconsistent on the website, for example. So this might be difficult. Sometimes you have dynamic selectors that are injected randomly or in different times, so it's not straightforward to extract them. Sometimes you have content that's dynamically generated after you load the page using JavaScript, so it's not straightforward to scrape these things. So in some cases, in most of the cases, it's straightforward. With XPath selectors and CSS selectors, you can get the content. If there's already structured content, it's fairly straightforward. But these are some of the cases that might make it a bit challenging.
Okay.
Support JS websites. That's one big one, and it's important. We have to work on this together. I need your feedback, Andrea, on supporting JS-based website. That's not available right now, but it's very important.
Okay, this kind of workflow available with other tools outside of WordLift as well?
Yeah, I mean, as Elias was explaining, basically you can bring the data, and as I show, for example, I mean, you can bring the data and after play with the data as you prefer. Of course, I mean, here with WordLift, we focus on transforming this data in a search engine language that can be consumed. So basically, we build this knowledge graph, and after we provide it for the search engine. But I mean, the same approach can be applied. So if you don't want, for example, use the data for SEO purposes, you can just, I mean, use this data set with the scrolling for other purposes. If you want to build a mobile application, you can use it the same. I mean, here we focus on WordLift in the second part because, I mean, we are more on the SEO front. So we show how we can bring this data set and after build a product markup or another markup, but it can be used in very different ways, basically. Yeah, I see two questions here from Perdicis. I see one question was, so when you have massive stores, for example, an auto parts, if you have, for example, 250K SKU to be crawled. This is, I mean, a very good question. And let's say, I mean, this is one of the challenges that we face, especially when we work with the large corporation. Basically, I mean, this is something is quite important, and from our experience, I can tell you that we see some astonishing results, especially when we work with big websites. So what we notice, I mean, I remember in the last project we go live with maybe 500,000 products on an international website, multilingual website. what we saw that when we provide the data set, the impression goes too high. Because why? Because the search engine, they don't see only the information that you have in the web page. So when the search engine arrive and they crawl the web page, they can also go back and follow the data set that you have behind. And this is very important. Why we focus always on the data set? Because it's another input for the search engine that can provide information. So if you are working, for example, with the Google merchant, you have one input. You have, for example, the structured data in your website. This is another input. Then you have the data set behind. So you have basically more or less 3 inputs where search engine can collect information. And this, of course, will reflect too much on the visibility of the websites, because it's simple. More information, more data you can provide the search engine with, the more, trusted that you can get from the search engine. And of course, here the properties are very important. So if you are, for example, providing more images in your structured data, if you are providing more details like the color, the model, the brand, all this information will help the search engine, because you can also rank for this, for example, long-term queries that the search engine cannot bring directly from your web pages, because it's not so easy even for the search engine get all of this information. So if you are providing after the data set behind, then you are going to get everything that you need basically in order, to get your website fully understood by the search engine.
Yeah, and when you have a very large number of products, I think those distinctions between the products become very important. So
Exactly.
It's not just shoes. Like we have 1,000 or 10,000 pairs of shoes. What's different between this and this and this? So it makes it very easy to satisfy very specific queries. I don't know if you want to show the data set that you provide with WordLift, maybe, so everyone can see what, if you want to share an example.
Yeah, this
not.
is what I showed before. I'm not sure if I shared correctly it doesn't show before.
The knowledge graph on some pages that gets loaded dynamically to web pages.
I show insomnia, but basically, but I'm not sure if. Let me try again.
It's okay if not, but I think it's useful for people to see, and it makes it very
let me
clear.
know. You see it right now?
Yes.
Okay, yeah. So basically, yeah, this is, the data set that we have. So, this is not quite a huge data set, but the approach is the same, basically. When we have the data set, we can do a lot of stuff. Here, for example, you have a URL, school name, brand. So this is the idea behind. We can do a lot of stuff with the data set if we want. It depends on how large it is, but the approach is the same. If we have 1 million product, or if we have 1,000, the approach is the same. The important getting this data set, and then we can use it in the way that we prefer. If we want to build the product markup, or if we want, to build the knowledge graph behind, we can do whatever with this data set. Okay, this is one for you, yes.
Right now, as I mentioned, we were not scraping JS, but Selenium is very good for this approach. Selenium is a great tool for that, but right now we're not using it.
Okay, so enrich merchant center and the schema, all page optimization, interlinking.
You'll get a thank you letter from Google if you do all these things.
Yeah, exactly.
They will say, "I love you, thank you."
One thing, that I see, Google was telling us, very clearly, I believe Valentina also has wrote an article about this, that provide both. They were focusing too much about the merchant center and the structured data, and they explain exactly why they prefer these 2 inputs. Because we have 2 different approaches there, because the merchant field is immediate, so it's a kind of providing information immediately for the search engine that they can see in real time. Then we have the structured data that we know it's not immediate, because Google can crawl the website each 2-3 days. It depends, how website is large. But providing both of them basically will be perfect, especially if your data is aligned, because I mean, it's all about game of trustness. So if you have your merchant feed, you have the structured data, both are aligned, you are providing everything, then that's it. I mean, if you do all of this stuff, this is quite good. And you have, I mean, there is a lot of margin to improve. I mean, imagine only how many properties I can add for a specific schema markup. I mean, it's unlimited. You will add a lot. I mean, and you will find always, I mean, some margin to improve.
More details to add.
Exactly. And here, with the web scraping, it's great. Why? Because I mean, for me as a CEO, even I am struggling to get all the data. Sometimes even for the same clients, they don't provide me with all the data that I want. So the scraping solution is a great here because it can complete this field that I don't have. Then I can improve the markup that I have on my website.
Very good question. So we have dynamic prices. This is where.
Yeah, exactly. So here, I mean, there is a specific markup for the price range. So if you don't have a specific price, basically you can provide the price range from to, and that's it. If you don't,
I think we can share the link maybe that shows that this gets dynamically injected into the page. So if you have different prices, this one goes into your page when the user. Does that make sense? The one that I just shared with you?
Yeah, it could be. I mean, it's easy. I mean, if you don't have the fixed price, just give the range that you have, and that's it.
Okay.
Yeah.
So this is a WordLift thing where the data is hosted somewhere and requested when someone goes to the page. So if in case it's dynamic, as Sayed mentions, you can change the pricing continuously over there, or if you have stock information.
Yeah. I mean, you are speaking about the dynamic of the pricing, of course. I mean, especially for example, in e-commerce, we know that the prices change every day. So once we have the stuff, I mean, change it, then you are going to get it updated in the knowledge graph, and after you're going to get it updated directly from in the other distribution channels.
Okay, so if there are not any more questions, I can say thank you both, and see you soon.
Thank you, everyone. Hope you liked it.
Thank you.
Thank you.